just like how some things grow very quickly over time, there are some things that decrease very quickly over time. So when we look at exponential decay, so some examples of things that will do that is like medication. So when you take a certain medication, okay, you get like, the big amount in your system and it kind of wears off quickly for a few hours. And then after that, it sort of takes a little while for it to kind of even out of your system. So that's why, like, sometimes when you first start taking a medicine, they'll have you take like a double dose at the beginning, so that you kind of get that buildup in your system. But then as time goes on, you can't keep taking that same amount because there's still some left over from your last dose. Okay, so you kind of notice I had this backwards on here. I had to fix it. Okay, the value of a car also decreases exponentially over time. So to kind of illustrate that for you, I did a little bit of research. So I went online to kellybluebook.com, which talks about values of cars. And I looked up how much a Toyota Camry is worth, okay? Because that's just a car that I knew of that has been around for a really long time. So here's some numbers that I pulled. So if you buy a brand new 2021 Toyota Camry, it's going to cost you about $27,000, okay? If you buy a 2020 Camry, so about a year old, the value of that car drops to about $22,000. Okay, one more year older and it drops all the way down to $14,000. That's a big drop, right? Okay, a 2018, 13,000, then 11, then 10. So when you look at these numbers, we're dropping by 1 year every time. So the amount of time has stayed the same. But like from here to here, we lost like $5,000 worth of value, right? From here to here, we lost like $8,000 worth of value. And then from here, it's sort of like, it's still dropping, but it's only dropping by about 1,000, right? So there's a huge difference here. It dropped really quickly in those first couple of years. But then after that, it sort of balances out. And then I kind of said, okay, well, what if I jump like really far back? So I said, well, what about a 2020 Toyota Camry? So I jumped all the way back to 2020, and the value of that car, it's not worth a lot. It's about $1,800, right? So did we drop a lot from 2016 to 2000? Yeah, over 16 years, the value of that car dropped by about $9,000, right? But compare that to back here. From 2021 to 2019, that's only 2 years. That was more than $9,000. So it jumped more in these 2 years than it did in these 16 years. Okay, so the value of this car drops really quickly at first. And then, it keeps dropping, but it drops slower. Okay, and if you think about it, like the value of the car is never actually going to get to zero, right? Cars are always worth something. Even if they're like broken down and scrap, you could still, give it to a junkyard somewhere and it'd be still worth something. So the value of your car would decrease over time. It decreases really quickly at first, and then it starts slowing down how much it's dropping. Okay, so that's kind of what we're looking at with exponential decay. Now, here's our equation for exponential decay, and you are going to notice that it's going to look surprisingly similar to our exponential growth equation, right? Here was our exponential growth equation. And when you compare them, they're almost exactly the same. The only difference is that a decay has a minus sign and a growth has a plus sign. So let's take a look. Defining these variables really quick. Okay, just like the last time, A is going to be your starting amount. R is going to be your rate. And again, it has to be a decimal. T is time. And you use all of that to get you your final amount. Okay, great. So let's take a look at this. We got a car that's worth about $21,000. It loses 12% of its value every year. How much is it going to be worth after 6 years? So let's write our equation. So my final amount, that's what I'm going to be looking for, is equal to my starting amount, $21,500, times 1 minus the rate, right? And remember, we have to move that decimal point over twice. So it's going to be 0.12. And we want to know after 6 years, so I'm raising that to the 6th power. All right, so let's throw it in our calculator. So 1 minus 0.12. All right, and then I'm raising that to the 6th power. and then I'm multiplying that by the original value of the car. So it's going to be worth about $9,985, rounding to the nearest dollar. Okay, so after 6 years, look at that, right? The value of the car, it dropped by like half, right? It's only worth half as much money after 6 years. All right, second example, we've got a particular type of medication. All medications work differently with your body, so they all drop at different amounts. This particular one, you lose about 15% in your body every hour. So the initial dose is 500 milligrams. It's not safe to drive if you have more than 50 milligrams of this stuff in your system. So if you have to leave the house in 3 hours, are you going to be able to drive, or do you need somebody else to drive you? So what we're going to figure out is, let's figure out, well, how much will be left in your blood system after 3 hours, and then we can compare it to the 50. So my final amount is going to equal the starting amount times 1 minus my rate. And remember, we got to slide that decimal point over twice. And then raised to the time, that's 3 hours. All right, hand dandy calculator, 1 minus 0.15 raised to the third power. And then I'm multiplying that by the initial amount. And it works out to 307 milligrams. So after 3 hours, you're still going to have 300 milligrams in your blood system. Are you going to be safe to drive? Nope. Right? You're definitely going to need somebody to help you out, because you can't have more than 50 and we're at 300. Definitely not safe to drive. So not safe to drive. Okay, so these are the kind of things, this is sort of the math they do when they tell you like how long you need to wait between doses on medications or how long you need to wait to drive. This is the kind of math that they do. Okay, so that is how exponential decay works.